Hi everyone, we're going to determine whether the given sequence is arithmetic, geometric, or neither. And if it's arithmetic, we're going to state the common difference. And if it's geometric, we're going to state the common ratio. And the main thing you need to know about this is arithmetic sequences are linear. And geometric sequences are exponential. And if you can recognize that, then this is going to be a lot easier. So, for example, this one right here looks linear. If you wrote this as like y equals x plus 2. Alright, so that's what that would be like. So this is linear, that means it's arithmetic. And your common difference is just going to be whatever the slope is of that. So the slope of that is 1. You could also write it out. You write out the first term and second term and write it out that way and see the common difference as 1. But this goes faster if you do it this way. We know this looks linear, so it's arithmetic. Let me put A here for arithmetic. So the common difference is 2 because our slope is 2. Now this one here is not exponential. This is quadratic. This one is also quadratic. It's not exponential, so this one would be neither. So we don't have to do anything with those. Right, the next set we have is this set. This looks linear, so it's arithmetic. This looks linear, so it's arithmetic. This is exponential, so this is geometric. This is, the last one is geometric as well because it's exponential. So what you do for the arithmetic one is find the slope. And the slope here would be negative 2/3. So my common difference is negative 2/3. You could also write out some terms and see that that's what's going to happen. Here my common difference is going to be negative 3/4. Now on the exponential ones or the geometric ones, you just use this number. It's always going to be that number, and we looked at that in a previous video. So your R is 2/3, your common ratio is 2/3. And your common ratio here is 5/4. Alright? And then on the last set we have just the list of numbers. This one we don't have a common ratio. I can multiply 1 times 3, but 3 times 3 is not 6. And I can add 2 to this, but I can't add 2 to this. So this one's neither. This one has no common difference or common ratio. Now this one looks like we keep adding 2. So you keep adding 2, that's going to be arithmetic, and the common difference therefore is 2. This one I keep multiplying by 2. So when I multiply negative 1 times 2, I get negative 2. Negative 2 times 2 is negative 4, and so forth. So the common ratio is negative 2, and this is geometric. And the last one here, obviously, is neither. It doesn't have a common ratio. This is your Fibonacci sequence. I should have spelled this. Fibonacci. Something like that. Okay. So basically, it's neither, and if you wanted to do more, what you're doing is you have the first 2 terms and you add them. So 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and you get 21. That's the Fibonacci sequence. It's not arithmetic, nor is it geometric. The last one we have are these exponential kind. I can rewrite this one as 3 to the 1/2 to the nth. So my common, this is geometric, my common ratio is 3 to the 1/2, which is really square root of 3. Alright, and this one is definitely geometric. My common ratio is negative 1. No, my common ratio is just negative 1. And that's all. Thank you and have a nice day. Bye-bye.